We're going to start on the next part of the topic, which is volume. We did surface area. Surface area, if you think of like cardboard box, it's all the cardboard that makes that box. Volume is a little different. Volume is the amount of stuff we can put in that box, which is totally different. So volume of a cube, it measures capacity. That's how much something can hold. And when we label it, it's always cubic units. So it's like centimeters cubed, meters cubed. Because it's three-dimensional, remember surface area is just a two-dimension shape. So when we did surface area, here's a cube, kind of, sort of. We found the area of this side. That's just length and width. That's only 2 units, right? It's two-dimensional shape, so that's why our label was squared. Volume is length, width, and depth. So it's three-dimensional, therefore it's feet cubed, inches cubed, centimeters cubed, whatever the label is, cubed. For a cube, all the sides are the same. It's length times width times height, but they're all the same, so it's s cubed for a cube. So number 1, find the volume of a cube with sides 8 centimeters. V equals 1 side cubed. So I would take that number, 8, plug it in. In your calculator, you'll see there's on the left-hand side above x squared, there's a arrow up key, a caret key it's called. So in your calculator, you would do 8 caret 3. That's for any exponent. You could do 8 times 8 times 8, but that key will do it all at one shot. And we get 512 centimeters cubed. Number 2, if the side of a cube is 3.5 inches, find its volume. Again, same formula, 1 side cubed. I plug in the one side, that's 3.5, and I cube that. So using the caret key, if I do that, I get the volume is equal to 42.9 inches cubed. And this is the answer rounded to the tenths place, like the directions say up top. Number 3, what is the side of a cubical box with a volume of 344? So I know in this case, the volume is 343, and I need to figure out what number multiplied by itself 3 times is 7. The easiest way to do this, later on in higher level math, you'll learn about cubed root, and it looks something like this. It's like a square root, but it's a cube root. We could guess and check though. If I just slap a number up here and see what it is cubed, like let's say it's 5. 5 cubed is 5 times 5 times 5, it's 125. That's not high enough. I could try 6 cubed. That's 6 times 6 times 6. 36 times 6 is 216, so notice it's going up. 7 cubed is 49 times 7, which gives me 343. So I found it, so one side equals 7 inches. So the easiest way until you get to a little higher would be to find, guessing and checking almost, what number would work. Number 4, find the volume of a cube with sides 1.7. So I'm going to ask you if you wouldn't mind trying questions 4 and 5 and 6. They're all like the ones we just did. Use the formula for each one. They're all cubes. Plug the numbers in, see if you can use your calculator properly, and round to the nearest tenth. Question 7, if you turn to that page, the diagram below shows a cube with side lengths of 30. So we have this cube here, and it's got 30, 30, and 30 side lengths, centimeters. A smaller cube with sides of length 5, so all these are 5s here, has been cut out of it. What is the volume of the large cube before the small cube is cut out? So it's a cube, and we're looking at volume, so that's S cubed. I plug in 30 cubed, so that's 30 times 30 is 900 times 30 is 27,000 centimeters cubed. So this is like if nothing was missing. The volume of the small cube that's taken out, I find that, is 5 cubed, which is 125 centimeters cubed. So the volume of the shape that's left over is 27,000, the big one, minus 125 that I took out of there. I get 26,875 centimeters cubed. So in surface area, we talk about cutting the shape into pieces and finding the area of each piece, or finding the area of the whole thing and subtract what's missing. This is kind of the same idea. We found the volume of the whole thing and subtracted what part was missing. The staircase below is built from wooden cubes with sides of length 6. So each one is 6, 6, and 6, even though it looks like rectangular. It is a cube. So each one is 6. What is the volume of the staircase? You'll notice there's 1, 2, 3, 4, 5, 6 stairs, or 6 blocks really that's used. So I find the volume of one of these, which is 6 cubed, and I get 216. That's for one. We found that there's 6 of them that make it up, so we multiply that by 6 stairs, and we get 1,296 centimeters cubed. It's the total in that many stairs. A similar staircase is 4 blocks high instead of 3. So we're adding, instead of 3 layers, 4 layers. What is the volume of this staircase? So we'll have 2 here, 3 here, and 4 here. So this is what it looks like. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 instead of 6. The volume is the same still. So 216, but now I have 10 cubes that make it up. So now it's 2,160 centimeters cubed. So drawing a picture will definitely help you making this question a little easier. Make sure you try those ones on the first page for me, bring those to class, and we'll talk about them.